First shock: Antarctica is not flat under the ice. The first major scientific surprise was simply this: Antarctica's buried bedrock is dramatically uneven. It is not a smooth stone platform under ice. It is a rugged continent of mountains, deep basins, ridges, and troughs. NASA's Bedrock Beneath Antarctica summary of the BedMap effort described a much more detailed hidden landscape than previously known, based on millions of new measurements, including satellite and airborne data. British Antarctic Survey similarly described Antarctica's underside as a landscape of mountains and deep canyons, rather than a bland subice surface. That matters for a reason far bigger than geography. The shape of the bed beneath the ice controls how the ice sheet flows, where it sticks, where it accelerates, where meltwater collects, and which glaciers may become unstable first if the climate warms. BAS emphasized that bed topography is a key part of understanding Antarctic ice sheet behavior. In other words, the hidden continent under the ice is not just scenery. It is the physical control panel for the future of global sea level. This is one of the deepest shifts in Antarctic science over the past few decades. Researchers used to think mostly in terms of the visible ice surface. Now they understand that the invisible bed can matter just as much. A glacier resting on a favorable ridge may behave very differently from one stretched over a deep inland basin. A subglacial valley can funnel ice the way a river valley channels water. If you do not know the buried shape of Antarctica, you do not really know the ice sheet sitting on top of it. And that is the first reason scientists were stunned by what they found. They were not just discovering objects under the ice. They were discovering that the buried land itself is far more architecturally complex than expected. The Gamburtsev Mountains, a mountain range no one should have found there. Among the most astonishing buried features in Antarctica are the Gamburtsev Subglacial Mountains, a massive mountain range entombed beneath the East Antarctic ice sheet. These mountains are often compared in scale to the European Alps, yet they are completely hidden beneath kilometers of ice. NASA and other polar science summaries have long treated them as one of Antarctica's great geological mysteries, because such a large mountain system should have left obvious traces if the continent were easy to read. Instead, it was found beneath ice. What makes the Gamburtsev Mountains so scientifically unsettling is not just their size, but their existence in the middle of East Antarctica, a region often imagined as geologically quiet. A continent hidden under a giant ice sheet already feels remote. A mountain range buried under that ice makes the place feel almost fictional, and yet these mountains are real, and they may have played a crucial role in how the East Antarctic ice sheet formed in the first place, because elevated terrain would have helped snow and ice accumulate when the climate cooled. That connection between buried topography and ice sheet origin is one reason the range matters so much to glaciologists and geophysicists. There is something psychologically important here too. Mountains usually define a landscape visibly. They dominate horizons. They organize rivers, weather, and movement. In Antarctica, you can have an alpine-scale mountain system and never see it from the surface because the ice has erased the view. That is the kind of fact that changes how a continent feels. Antarctica stops being a flat white mass and becomes something stranger, a place where even mountains can disappear. The subglacial lakes, water in a place that should be frozen solid. Then there are the lakes. This may be the most counterintuitive discovery of all. Antarctica is the coldest continent on Earth, yet beneath its ice sheet are hundreds of lakes. NASA Earth Observatory reported long ago that more than 140 subglacial lakes had been identified, and later NASA Earth Data Features said the number had grown to over 200. In 2021, NASA's IceSat-2 work helped identify and map more hidden meltwater lakes under Antarctic ice with much greater precision. ESA reported 85 new subglacial lakes detected below Antarctica in 2025, underscoring that the inventory is still growing. At first, this sounds impossible. How can liquid water survive under such a frozen continent? The answer lies in pressure, geothermal heat, and friction. NASA Earth Observatory explains that although Antarctica's surface is unimaginably cold, conditions at the base of the ice can be warmer because the thick ice insulates the bed. The pressure lowers the freezing point, and heat from the Earth plus friction from moving ice help create liquid water at the base. So even beneath a continent defined by ice, there are hidden hydrological systems in motion. This is one of the moments where Antarctica becomes almost alien, because the image people carry in their minds is simple. Frozen continent, frozen bed, frozen everything. But the reality is far stranger. Beneath the thickest ice on Earth, water can pool, flow, drain, refill, and migrate between lake systems. NASA's ICESat-2 and Earth data reporting showed that these lakes are not all static. Surface changes can reveal active subglacial water movement below. So underneath the frozen surface of Antarctica is not just stone, it is a hidden freshwater network. Lake Vostok and the idea of a sealed world. The most famous of Antarctica's subglacial lakes is Lake Vostok, buried beneath kilometers of ice in East Antarctica. It became one of the most scientifically compelling hidden places on Earth because it appeared to be a vast liquid lake isolated from the atmosphere for immense spans of time. NASA's Earth Observatory treated Antarctic subglacial lakes, including Vostok, as one of the major revelations of polar science, and the broader scientific fascination has centered on whether such lakes host unusual microbial ecosystems and preserve ancient climate or biological records. Lake Vostok matters because it made scientists ask a completely new kind of Antarctic question. Not just, how does ice flow, but what has been living, changing, or being preserved beneath that ice while the surface world remained locked above? Even without making exaggerated claims about life, the lake forced science to take seriously the idea of ancient, isolated subglacial environments. That had consequences beyond Antarctica. Subglacial lakes became important analogs for icy moons and ocean worlds elsewhere in the solar system. If liquid water can exist, remain isolated, and possibly sustain microbial processes beneath ice on Earth, then buried oceans on moons like Europa and Enceladus become more scientifically imaginable. Antarctica, in that sense, stopped being just a continent. It became a preview of worlds beyond Earth. And that is part of why what is buried under Antarctica feels so large in the imagination. Because it is not just geology, it is a hidden biosphere question, a planetary analog, and a climate archive all at once. A lost river world buried for millions of years. If the lakes under Antarctica are strange because they are alive with water today, the buried landscapes under East Antarctica are strange because they appear to have been frozen in place for immense spans of time. In 2023, a Nature Communications paper reported an extensive Relic pre-glacial river landscape preserved beneath the central East Antarctic ice sheet. The researchers described ancient river-cut surfaces formed before major ice buildup, then later modified by local glaciation and partly preserved beneath the present ice sheet. The significance of the finding was enormous. It suggested parts of East Antarctica have remained protected from warm-based ice erosion for millions of years, preserving an ancient landscape that predates the modern ice sheet. That is one of the most breathtaking ideas in modern Antarctic science. There are parts of Antarctica hidden beneath the ice that may not have seen the open sky for tens of millions of years, and yet the shape of those surfaces still reflects ancient rivers. The continent is hiding landscapes older than the ice itself. Bass expanded this picture in 2025 by highlighting ancient river surfaces near the East Antarctic margin and noting that these preserved flat surfaces may slow the movement of glaciers above them. Bass quoted researchers calling the landscape under the East Antarctic ice sheet one of the most mysterious, not just on Earth, but on any terrestrial planet in the solar system. That is an astonishing sentence, but it is earned. Few places on Earth are so physically inaccessible and yet so important to understanding planetary history. This discovery changes Antarctica from a frozen, present-tense continent into a layered time machine. The ice above may be modern in geologic terms. The land below can be ancient beyond ordinary intuition. Hidden rivers that flow under the ice. And the story gets stranger still. The water beneath Antarctica does not only sit in lakes, in some places, it flows in rivers. ESA reported as early as 2006 that scientists had discovered rivers the size of the Thames flowing hundreds of miles under Antarctic ice shelves by using satellite-detected changes in ice surface elevation. More recently, major reporting and scientific mapping have highlighted hidden subglacial river systems in East Antarctica and near important glaciers. The idea of rivers flowing uphill can sound sensational in press summaries, but the deeper point is that these are pressurized, bed-controlled meltwater systems behaving in ways very different from ordinary surface rivers because they are confined under ice and driven by pressure gradients as much as by topographic slope. This matters enormously for ice sheet stability. Subglacial water can lubricate the bed, alter how fast ice moves, and influence where melting and refreezing happen. Hidden hydrology beneath Antarctica is not a side issue. It is part of the machinery controlling how the ice sheet behaves now and how it may respond in the future. That is one reason scientists care so much about mapping these systems. You cannot predict Antarctica's future by looking only at the top of the ice when so much of the important motion is being shaped from below. So, under Antarctica's frozen skin, there are lakes, rivers, and channels, a concealed hydrological world that most people never imagine when they think of the coldest place on Earth. The hidden continental structure below the ice. There is another buried Antarctica beneath the hydrological one, the deep continental architecture. Researchers have used geophysical methods to infer that East Antarctica consists of multiple ancient crustal blocks and remnants of old continental assemblies. Although this is less visually dramatic than a lake or mountain range, it matters because Antarctica is not one simple slab of crust. It has a deep tectonic history, and the ice has hidden much of that structure from easy study. The fact that even the continental skeleton of Antarctica is partly concealed by ice helps explain why major geological surprises keep emerging there. This contributes to the eerie feeling of the continent. You are not just dealing with one hidden layer. Antarctica has hidden layers stacked on hidden layers. Ice, water, landscapes, mountain systems, old tectonic structures, and ancient environmental records. Each new imaging method strips away one level and reveals another beneath it. That is why Antarctic science often feels less like normal fieldwork and more like archaeology performed through geophysics. The ice was hiding a real continent. The first great revelation beneath Antarctica is that there is a real continent under there in a much richer sense than anyone once imagined. Not just bedrock under ice, but mountains, basins, ancient river-cut landscapes, hidden lakes, flowing subglacial rivers, and geological structures that shape the present behavior of the ice sheet. NASA, BAS, and recent peer-reviewed studies all point to the same truth. Antarctica's hidden underside is one of the most important and least intuitive landscapes on Earth, and the deeper implication is unsettling. What lies under Antarctica is not only ancient, it is active. It influences modern ice motion, modern sea level risk, and modern planetary science. The buried continent is not a fossilized curiosity. It is part of the living Earth system now.